So we can share these electrons equally between two atoms where they're each pulling with an equal amount and they're sharing those electrons kind of right in between them. That's one of the things that we can do whenever we share electrons between two atoms. This right here, when you share electrons equally, is actually called a nonpolar covalent bond. And what that means is because there's equal pull, you're not creating a partial positive or a partial negative. You're not doing that. It will happen occasionally because of chance or random movement of electrons, but all in all, the element doesn't have a partial positive or a partial negative charge. Because of that, this is an extremely weak bond. Okay, these things tend to be gases at room temperature, and they're not held together very well at all. The shared electrons happen between two atoms that pull equivalently. Now, the most common nonpolar bonds are what we call the diatomics. And a diatomic is one in which you have two of the same atom bonded together. So the example we have here is chlorine, which is a diatomic. You also have things like fluorine. You have things like oxygen. You have things like nitrogen. All of those represent what we call nonpolar covalent bonds because they're diatomic. It is also possible that you can have what is very, very close to a nonpolar covalent bond if two atoms are very close in their electronegativity values. So what you need to do whenever you're trying to determine if an atom has a nonpolar covalent bond is you look at the periodic table and you look at the electronegativity values. If you look over here to the right, in group 16, you have oxygen, which has a value of 3.44. In order to see if there's a nonpolar covalent bond that goes with it, you look for something that's around 3.4 as well. And if you look, there's actually nothing that's close to 3.4. But nitrogen at 3.04 is very similar to bromine at 2.96. Yes, they're a little bit off in terms of they're not exactly the same, but they're both very close to 3. So as a result of that, you could say that nitrogen and bromine would form something very similar to a nonpolar covalent bond. Now, if you share electrons equally, you can also share electrons unequally, in which one atom pulls the electron a little bit more. You have this famous quote from Animal Farm, says all animals are equal, but some are more equal than others, and you can say replace animals with atoms. All atoms are equal, but some atoms are more equal than others in terms of the electrons. So the shared electrons tend to gravitate towards one atom or another, and that's what you get here when we talk about polar covalent bonds. What you see here is this is oxygen and hydrogen, and these two are sharing these two electrons. But if you look, the electrons have gravitated towards the oxygen. The reason why is oxygen has a higher electronegativity value. Same thing happens over here. These should be here in the middle shared equally, but they're not. They tend to gravitate towards the oxygen. As a result, oxygen has what we call a partial negative charge, while the hydrogen has a partial positive on both sides. And that's because hydrogen has a lower electronegativity value. And we can go to our periodic table and we can say, okay, hydrogen's in the top left corner, it's 2.2. Oxygen's over here in group 16, it's 3.44. And as a result of that, what we can say is, all right, since this is the case, there's a difference of 1.2, and that's a pretty significant difference. So we can say that that right there is what we call a polar covalent bond. Here's an example. It says, using your periodic table with electronegativity, determine an element that will form a nonpolar covalent bond with nitrogen. And so we look at our periodic table and we say, okay, there's nitrogen. Nitrogen's in group 15, it's element number 7. It has a value of 3.04, and the closest thing that we have would be probably bromine. Now, krypton does have a small electronegativity that's there, it's at 3. It tends to be excluded for the most part because it's a noble gas, so I would say that the best bet in this case would probably be bromine at 2.96. In this example, it says the carbon-hydrogen bond is the basis for life as we know it. Describe the type of bond formed between carbon and hydrogen using your periodic table of electronegativities. So we go back to our periodic table of electronegativities. Remember, we're using p-table for those of you who couldn't remember where we got here. And if you look, hydrogen is in the top left corner. It has a value of 2.2. and carbon has a value of 2.55. So that is going to be a slightly polar bond because there's a difference of 0.3. It is getting pretty close to where it could almost be considered nonpolar, but it is still a difference of 0.3. So we do still say that this is actually a slightly polar covalent bond. So the degree of polarity actually matters. If something has a difference of like 1.2, it's going to be a very polar covalent bond. If it's something like carbon hydrogen, where it's a difference of 0.3, it is a slightly polar covalent bond. So you should be able to rank the polarity of a various sets of bonds and say, yes, this one is more polar than this one, for any sort of quiz or test.